Hi, everybody. It's lovely to see you all here. Thank you for taking the time and for attending, and I really hope you're attending. You're enjoying SmartCon so far. I know you're attending. Today, I'm going to talk to you about the power of the Chainlink Node software, its history, what it's doing today, and where it's going, where we're going with this. First, let me introduce myself. My name is Zubin Pratap. I'm a developer advocate at Chainlink Labs. Before this, I was a software engineer at Google. These have been some of the best jobs I've ever had in my life. Before that, I was a corporate lawyer for about 15 years. Makes me appreciate engineering a lot. I guess we should start by talking or understanding what the Chainlink Node software is. So Chainlink Node software is how we at Chainlink solve the blockchain Oracle problem. And you're probably wondering, what is this blockchain Oracle problem? Well, blockchains, as some of you may know, have to synchronize their state, their data across multiple nodes across the network, which means that they need to be fundamentally deterministic in order to achieve consensus, which also means that they can't connect to the external world for data and events the way we'd like. So this raises a very, very big question. How do our smart contracts that are locked up on a blockchain interact with the real world and consume data in a way that does not compromise in any way on the chief tenets of blockchain technology, which is transparency and immutability? And the answer is oracles. But not just any oracles. We need them to be decentralized oracles, which is what Chainlink Node software is all about. So Chainlink Node software is open source software that runs on a computer. Let's just call it a Chainlink node. And these nodes, they provide Oracle services so that your smart contracts on a blockchain can connect to external world data, which makes Chainlink Node software a kind of middleware. But Chainlink nodes don't just run any garden variety Oracle software. They're not just giving you access to external events and data. They're also able to help you move some of your compute off-chain. But we'll talk more about that in a little bit. As you can appreciate, any meaningful solution to the blockchain Oracle problem must absolutely satisfy those North Star principles that are so important to us as participants of this movement, right? And Chainlink Node software connects your smart contracts with external data and compute in a way that achieves greater decentralization with no loss of the essential properties of trust minimization through verifiability and at ever-increasing levels of scale. Plus, the Chainlink Node software is able to achieve significant transaction cost reduction for you because it is able to run those complex computations that we talked about off-chain. So you're not spending a ton of gas on compute, right? But all the while, you're still maintaining cryptographically verifiable integrity. And being open source software means that the Chainlink Node software provides you with a platform that enables any interested community member with the right know-how and the right infrastructure, I guess, to spin up their own node and contribute to the increased decentralization of the Chainlink Oracle networks. And as you can appreciate, to achieve this, it's not a simple feat. It's quite a complex achievement in terms of engineering and math, right? It's the kind of stuff that Chainlink research engineers, software engineers, and product people have spent years in designing, building, and testing. Today, the Chainlink that many of you have come to know and love embodies all those principles I talked about. But you know, it wasn't always that way. There was a time when Chainlink nodes, not too distant past as well, Chainlink nodes were once a fairly simplistic and naive kind of Oracle system, right? They used a system called run logs, which meant a single node would query a single API, get that data, post it on-chain. And if you had multiple sources of data, you'd need many nodes pulling data down and putting it on the chain. And all the aggregation and compute work was done on-chain. So being a single node meant kind of a single point of failure, not very decentralized, not very scalable, and all the aggregation on-chain meant high transaction costs, right? But it proved the concept. It proved the concept, and that's where it all started. After that came the Flux Monitor invention, which was not just a regular incremental improvement. It was a step function change, because not only did it support more nodes, it also was able to monitor data for freshness. As you can imagine, that is critically important for use cases like finance, right? So the Chainlink nodes could monitor data to make sure that they were up to date. And it would do this in two ways. Either data that was stale would get updated, so efflux of time, or data that had deviated past the last known value past a certain threshold would trigger another round of updates and automatically update the data. So that was a giant innovation. Along with that came VRF version 1, right? Verifiable random functions. Now, for those of you who are technical, you may appreciate that getting random numbers on a blockchain, kind of infeasible and highly insecure, right? And so, because they're deterministic systems. And so, a number of use cases like blockchain gaming rely on randomness in order to do, the games to work right. And so Chainlink was able to provide verifiably random numbers. How does it do this? It computes the random number off-chain and submits the random number plus a cryptographically verifiable proof of randomness onto the blockchain. This unlocked all these use cases in blockchain gaming. It also unlocked a number of use cases like where DAOs needed to randomly elect members from the community to participate in a committee and so on. And then, more recently, there have been much bigger innovations, and Chainlink node software is no longer just confined to EVM-based chains. It also supports non-EVM-based chains like Solana, right? And the new evolution of this is powered by something known as the Dawn. Not that Dawn, but this Dawn, the decentralized Oracle network. And what that is think of a Dawn as a cluster of independent, unrelated nodes that do a lot of the heavy lifting. They do a lot of they fetch data, they do off-chain compute, they aggregate the data, and then they submit a single transaction onto the blockchain. And you can imagine exactly how dramatic that reduction in cost is when you're just doing one transaction to the blockchain, right? Just one post to the blockchain. Sometimes it's more than a 90% reduction, drop in your costs. And what's exciting about this is that Dawns, because they're large networks of unrelated nodes, they solve the problem of decentralization. They solve the problem of scalability with no loss of the essential property of trust minimization through verification, right? So Dawns are a massive jump in the kind of decentralization that we can achieve. And Dawns are powered by something called OCR, the Off-Chain Reporting Protocol. Now, OCR is a consensus protocol for a distributed and decentralized cluster of unrelated nodes. What it allows is for these nodes to coordinate among themselves. And they're unrelated nodes, right? So these nodes, for example, each one of them is a reporter. And there is one leader-elected node that keeps rotating around. The OCR protocol handles that. And all the reporting nodes go away, fetch the data, compile it, send it to the one leader-elected node. That leader-elected node then aggregates all that data, produces one single compiled report, sends it back to each of the reporting nodes and say, hey guys, can you just authenticate this and verify this cryptographically that this is right? Once that's done, the single compiled report is then submitted on-chain, where an Oracle smart contract verifies that report and checks that all the signatories, all the signing and reporting nodes did in fact do this report or sign off on this report. And then that data gets persisted in the blockchain, right? So it is an incredible, incredible piece of technology. And as you can tell, I'm super excited about it. So why am I excited about it? Because everything about it, the cryptography, the protocol design, the software architecture, the incentive mechanisms, all of it is carefully, carefully calibrated to ensure that we move the needle on all three of the Holy Trinity: decentralization at ever-increasing amounts of scale with no loss of trust minimization through verifiability. We don't need to trust intermediaries. We just need to trust the math. Now, along with Dawns and OCR version 1, the VRF, the verifiable random function, also evolved considerably. So VRF version 2 came out, gave developers more control, a little more configurability, but also you're no longer confined to one random number. You can now request hundreds if you like, and each of them will get their cryptographic proof along with it. Also, around this time, around VRF v2, came the Chainlink automation network, right? What we called Chainlink Keepers. Yesterday, we rebranded it and announced we're calling it Chainlink Automation. So what that does is it automates the execution of your smart contract, which means you no longer need to rely on a developer or any other sort of centralized single point of failure to trigger your smart contracts. Why is that important? It's part of the decentralization process and trust minimization process. So you can now ask Chainlink oracles to trigger your smart contract for you. And you can do this in two ways. You can use a time-based trigger. For those of you who are developers, you're familiar with cron jobs. It's a cron-like time-based trigger. Or you can run custom logic, right? Which means you can just programmatically trigger your smart contracts by running a piece of smart contract logic that the Chainlink automation network will trigger for you automatically. So massive innovations. Now, let's pause here for a moment because I've been rattling on top speed. We're talking about decentralized Oracle networks that cryptographically verify off-chain information, do off-chain compute. They coordinate and maintain consensus across a large network of decentralized and unrelated nodes. They generate verifiably random numbers on demand for you, and they're able to automatically trigger your smart contracts in a decentralized way. These are some pretty massive, massive achievements, right? In order to do this and support really sensitive cases like DeFi, there's a lot of technology that goes into this. Not only is it for the EVM chains, it's for multiple chains. So we need to maintain things like node quality, quality of service, response times, latency. We need to maintain decentralization and consistent behavior across all the different networks, right? And for those of you who are technical, you know that nonce and transaction management is painful, right? Then you have to worry about things like latency and response times across multiple blockchains. Each blockchain has its different block times, and you have to make sure your response times are within that. And you have to handle things like block reorgs without losing the data or the verifiability of it. So that sort of technical engineering is really non-trivial, and it's taken a ton of research and development effort and a ton of engineering time to do this right. So what next? The future, as I like to tell my mom when she's like, what is it exactly that you do? I'm like, the future, ever since I've joined Chainlink, honestly, the future is not what it used to be, right? At Chainlink Labs, I get the privilege of working every single day with people who are striving relentlessly to build the future we want, a future that is powered by cryptographic truth at scale, right? So next, DONs are going to be extended to support even more nodes, to achieve even greater decentralization. They're going to be extended to power VRF version 2 and whatever comes after that. They're going to be extended to power automation and keepers. Then, let's talk about CCIP, right? For those of you who know, cross-chain interoperability protocol. That's a way to basically do secure messaging and transactions across blockchains, to interconnect blockchains, if you like. Super exciting, and it's built on version 2 of OCR, of the off-chain reporting protocol that's coming out. So it's built on top of that, and CCIP is a way to enable people to communicate across blockchains. But that then enables the token bridge, the programmable token bridge. And Chainlink is building a reference implementation of a token bridge that is programmable, which means you can transport tokens across blockchains, but also as a developer, you can run custom commands on the bridge, right? Custom code. You can run issue commands to the bridge. Super exciting. Cannot wait to see the use cases that get unlocked from something like that. Right. And finally, crypto economic security. As you know, we're here to build for the long term. We think in terms of forever. We want this to be sustainable, right? That's why we're supporting the systematic rollout of crypto economic mechanisms and incentives that will drive the token economics for the entire ecosystem. Yeah? We want our community members to be rewarded for meaningful participation. We want our node operators to be completely sustainable and secure the network at scale forever. We want everybody involved in the movement who are participating to have the right behaviors that secure the network sustainably for the future, right? Because there's no end to how much we can scale these decentralized Oracle networks. Now, I know I've gone through this like a freight train blasting through it. It's a lot to take on. It's a lot to actually talk about in 15 minutes. But I thank you for your attention. I thank you for your interest. I thank you for being here. Most importantly, that's the code. That's the repo for the Chainlink node software. Take a look. Don't believe me. Go there, take a look, verify it for yourself. You don't need to believe me. Thank you.